Hello, it's been a long time since I've given an update on the progress on my horizontal boring mill. The progress has been very slow. I've been pretty busy in my shop, so I haven't had a lot of time to work on the boring mill. But since the last time I gave an update, I have done a few things. I took the outboard support and I stripped it down to pieces and cleaned it really well, and checked out all the parts, did a small modification where I drilled a hole in the sort of the locking mechanism for the spindle, which in the future will allow me to attach a digital readout to the spindle. I rebuilt it enough that I was able to put it back on, and I've done some work on the back end here under this bag. And that's just a few of the parts, but I still have more parts to put together, and I have a bunch of parts here that all have to be cleaned and put back together to finish the outside end of this outboard support for the spindle. I also had mentioned in the last video that I needed to go through the motor, and I did, and I believe I had said that I was going to open it up and clean it and repack the bearings. I got it partially opened up, and as you'd kind of expect, because it's a totally enclosed fan-cooled motor, the inside was essentially spotless. Nothing really gets in there. But I also noticed that the bearings were sealed, so they're not bearing you would necessarily have to repack. And when you turn the shaft, it was just smooth as could be. So I think the bearings are in very good shape. So I closed it back up, and then I just cleaned the outside, and there's a fan in here. I cleaned it up and just put everything back together, and then I reinstalled it on the head. So those are done. Other thing I did was this feed direction transmission that I had shown in the last video. It was full of sludge and was in bad shape, and I said I was going to rebuild it. I did. I'll show some pictures at the end. Just like the other work I did on this, I didn't really take any video, but I do have some pictures, and I can show how what the gearbox looks like inside after it was rebuilt. I stripped it all down. The gear case sealer, the paint they put on the inside of it, was flaking off and kind of a bit rusty, and I didn't want that flaking off and getting into the new bearings and the seals that I was putting in this gearbox. So I stripped it with paint stripper and a lot of wire brushing, and it actually was quite a bit of work, but I got the bulk of the paint out, and I got it so that nothing else was flaking. And then I just painted the inside with gray Tremclad, same paint I used on the outside. I've been painting my workbenches with gray Tremclad for over 20 years. My workbenches always have oil on them, and it just does not seem to affect the paint whatsoever, so I figured it was a pretty safe bet. The other thing I did, I replaced every bearing and all the seals in this gearbox. Some of the bearings were seized completely solid. That shaft back there with the keyway in it, that drives the lead screw to raise and lower the head. The bearing just below that cover, the outer race might as well have been welded to the inner race. For all the movement you could get out of it, it was just completely, the balls were rusted solid to both races. And there was, I don't think the guy that owned this before me was able to raise and lower the head. I don't see how he could have. But anyways, I replaced every bearing, and the 4 electromagnetic clutches that are in here each one has a hardened ring on it for a brush to ride on to supply the power to the coil, and the rings are in pretty bad shape. It almost looked like they'd been melted, and they had sort of divots in them, but like I said, they were hardened. So I stripped the clutches down, put the part that had the ring on my lathe, and with a tool post grinder I ground them back, got them round and smooth. Again, I don't have any footage, I don't have any pictures of me doing that. But I do, in the pictures I'll show, you can see the result, and the rings are nice and smooth and shiny. So I think that should work pretty well. I also replaced the wiring down into that gearbox. The old wiring was, the insulation was brittle and breaking off, so I bought some special oil resistant wire and I used that. My goal was to get all that, and there's also the lead screw and the feed shaft that have to go in, and the column cap and the counterweight chain and the end of the support all done, and get that essentially all completed. And then I was going to move on to the table and saddle. This morning curiosity got the best of me, and I decided to just take the weight covers off the saddle and have a look, just so I'd have an idea what I was going to be up against. So that's what you can see here. And one thing that surprised me was that the ways appear to be soft. They're all flaked, and the ways on the bed and the ways on the column are hardened and ground. So I was a bit surprised to see that these were soft and flaked. They appear to be in really good shape. If the flaking is to be believed, there's no wear. You know, you'd expect to see the majority of your wear in the center, and the flaking is not worn at all. However, I have my suspicions that this may have been reflaked at some point. It just seems a little too good to be true. And on the side, the flaking out here looks pretty good. As you move into the center, you can see it becomes less and less. And so I think what may have happened, you'd expect more wear in the middle. That's where the bulk of your movement takes place. I suspect that if the side was worn like that, and the top probably was as well, and someone reflaked the top. But anyways, they're smooth, and there are little, I don't know if those will show up. You can see the little lines here, which you would expect to see from cable sliding back and forth. But I won't know till I do sort of alignment checks once I get it all back together, if there's much wear there or not. I also wanted to see, I knew there was gearboxes and clutches in here. This is actually pretty simple compared to the other gearboxes I've been in so far. So this shouldn't be too bad of a job to strip down. You can see, like, all the gearboxes in this machine is just full of sludge, and it needs to be cleaned out. There's 3 oil compartments in the saddle. There's this sort of transmission area, and out here they're connected, and they're just filled with oil up to a certain level, and that lubricates the gears. Doesn't really do a lot out here. I think it's just a reservoir, so there's some extra oil. There's here where you add oil, which actually I originally thought put oil in here, but it actually has nothing to do with that. It goes in here. This is an oil tank, and there's the hand pump, and you pump, there's the hand pump, and you pump that, and that pumps oil through a series of tubes just like you'd expect, and it lubricates the slideways and probably the one lead screw nut. So that's a separate oil container. And then there's a third here, and it's an oil bath for the lead screw. And it's low right now. The lead screw's not really getting in the oil very much. But again, I'll clean all that out and then fill these up properly with the right oil in the right amounts, and it'll be clean. And the way I'm gonna use this boring mill, I think it'll stay clean under here. Like, again, with the aluminum swarf, like in the headstock, it's just all over. And the weight covers on this thing are rock solid. I don't know how the hell you'd get any swarf in there, but there it is. And so I'll get that cleaned out, and I shouldn't have to worry about that again. The gears here, this is here's these shafts. You have the lead screw, and that's for the saddle to move down the bed. And then there's a feed shaft that's fed from the direction, or from the gearbox over there. And when you turn this shaft, you can see that bronze gear turns, and then all the gears in the transmission here turn, and this turns really easy. There's almost no friction, and it's very, very smooth. So I think everything's in good shape on this gear train. But the way it works is you send power down through that hole into this transmission. The 4 clutches select forward and reverse for either the lead screw to raise and lower the head to go up or down, or to turn this shaft, which goes in the gearbox, and then that in turn turns this shaft either this way or this way and drives this gear train either that way or that way. If you engage this clutch, then this shaft turns, and there's a crossed helical gear that goes down below, and below that is a rotating lead screw nut. And that lead screw nut runs on this lead screw. This lead screw does not turn, it's stationary, and the nut spins, and that moves the saddle back and forth down the bed. If you select this clutch, obviously it turns this lead screw, and then that pulls the table back and forth across the saddle. So it's pretty simple and straightforward. And again, the direction of travel of either of these is controlled by that gearbox there. Another thing I found out about this, and I imagine probably most boring mills have this set up, but it has a nice way of returning coolant to the tank. You get coolant, you're cutting on the table, and coolant flows into the T-slots and runs to the end and gets in this trough, and it slopes down to this sort of sump, and then there's a passageway that goes in, and then there's another one on the other side that comes in. And I don't know exactly what it looks like under the table because I haven't taken the table off yet, but the coolant, I assume, no matter what angle the table is at, pours into another trough underneath, and then down under here, you can't really see it, but I can show a picture. There's 2 copper pipes that come down about 1 inch in diameter, and they just let the coolant pour into this trough. This is, oops, my hand out of the way. This trough, which is cast in, goes from one end to the other, and it slopes towards the center, and in the center is a hole. And down at the bottom of the hole, what you're seeing is the space between the bedways. There's a sort of a floor there that's cast into it. There's a dam cast in the end, so coolant can't pour out the front, and it slopes down relative to the bedways, so the coolant will run all the way back down the bed, come underneath here, and then it drops down into that kind of sump, and then there's another passageway there, flows under the gearbox, and comes out there where that rag is. Obviously there was a elbow or something bolted on there, it's long gone, but I'll make one, and then it'll just come out and pour down into a tank, which I'll make a tank up and put a coolant pump in it and a place for a skimmer, and then I can just pump the coolant back up. I'll have to figure out the piping, but it'll essentially go back up onto the head where I can control it so it goes on my cutters. So it's just kind of a neat setup without any external hoses or anything you normally find on milling machine tables. It's just all internal passages. They managed to conduct the coolant from the tabletop all the way to the back of the machine, no matter what position anything's in. So I thought that was kind of a neat setup. Like I said, maybe most boring mills have that, I don't know. I'm looking forward to being able to use that though. But that's essentially it. I'm not gonna really do anything to the saddle and table. I'm gonna just close these gearboxes back up, put the weight covers back on, and then just leave it. And then I'll start working on it when I get the head done. But now I have an idea what I'm gonna have to do when I do get to this, so won't be as surprising. Anyways, thanks for watching, and I'll put another update up sometime in the probably distant future. Thanks.